Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh, my dear students. Today we're going to discuss about the chapter number 3 here, that is uh, in which we're going to discuss atoms and elements. So let's see here before to start the lesson. Here it's couple of, you can say that the elements and atoms or few substances species are here. So we will find out that and discuss them in detail, why we name them atom or why we call them an element, or what's the difference between them. So let's see the first thing here. For example, it tells you sodium is made up of tiny particles called sodium atoms. So it's mean here you will find out that it is a sodium atom, okay, or these are a very small tiny particles, they made up of only with sodium, and we call this sodium as an atomic form in here. Now that is very famous thing and everybody want to get it, and it's very expensive. Yeah, that is diamond, is made up of carbon atoms, okay, different from sodium atom. You can see that it is if you can find out a pure thing here in the form of carbon, and that is made up of carbon atoms, so we name it as diamond. We not call it as carbon, we called it as diamond because it is an other form of carbon in which you can see it's in very expensive form. There is also another form of carbon that you can see in your pencils, we name as graphite. Yeah, in the lead pencil in which you have, that is called graphite, that is also a carbon, but it's much cheaper and it's too expensive. Now mercury here is made up of mercury atoms, different again. So you can see that it is totally changed from this one, or even state is also changed. Here it is solid form, but here it is in liquid form, okay. Now let's see down. Atoms are smallest particles of matter that we cannot break down further by chemical means. Understand? For example, here in the figure, you can find out on the screen this one. So like this one, it is an atom, inside it a nucleus, and that whole one is the electronic cloud, or you can say that the electron revolve around it. So what we can say about this, single atom are for too small to see. If like this, a dot, I make it here, okay, and you can piece or divide this dot, only this dot, okay, this one, not the ring, this one, you divide it, split it, or you can imagine that it's the 100th part of this dot, the atom may be smaller than that dot, okay. So you can see sodium only if there are enough sodium atoms together in one place. How can you see this sodium? If there are a lot of number of sodium atoms combined together, then you can find this sodium. In fact, atoms are mostly empty spaces. Look, this one. He tells you this inside the atom, the most space is empty. Yani nothing is there. Each consists of nucleus and a cloud of particles called electrons. These particles we name as subatomic particles. Like electron inside the nucleus, you will find proton plus neutrons and many other small particles. These are inside the nucleus. We name them subatomic particles. Understand, my dear? This drawing shows how a sodium atom might look magnified many millions times. Understand? So millions times when you magnify, you can see the sodium atom maybe like this. About atom, if you have any question, please.
No, sir.
Okay. Now the second thing here, we're going to discuss about elements. Sodium is made up of sodium atom only, so it is an element. Or you can say that An element contains only one kind of atoms. Only one thing if present in any substance, we name this is an element. Very easy. Yeah. Around 90 elements have been found in the earth and atmosphere. Now it's more because it is an old version of the book. So whatever written here, we just stick with this. Scientists have made early 30 others in the lab. Okay. Many of the artificial elements are very unstable. What it means? The artificial that you can say that you prepare, they are unstable. When you prepare, maybe they will vanish or they will just lost due to radiation or due to any reason.
They
And
can't live for a long
yeah,
time.
they can't be stable. They will maybe change into another substance and last just a few seconds before breaking down into other elements. That is why they are not found in the nature about the artificial one. After understanding the element, we move to the next part, that is the symbol of elements. If you remember, we already discussed this topic, but let's see again. What are the symbols? To make life easy, each element has a symbol. For example, the symbol of the carbon is C. The symbol of the potassium is capital K. And from its Latin name, Kalium, but we use name in the periodic table potassium, but for symbol we write K. Understand? Some elements are named after the people who discovered them. Many, like for hydrogen, we write H, capital H, but in the case of helium, we write HE. So the first letter should be capital and the second will be lowercase. Understand? Like same here, carbon, C, capital, but if you write copper, then you write Cu or CO for cobalt. It's
Why it's
easy.
small?
Yeah, it is a rule. Okay, how to write the symbols, or you can say that in the abbreviation form of any element, we use them, or that gives the you can say that a little bit relief to someone because when you're going to write a chemical equation, instead of you writing carbon plus hydrogen, then you will write something else, the product. So you write only C plus H, then your product. Okay, easy. Now,
Yes.
that is the most important part of the chemistry, or you can say that if without this, chemistry is nothing. That is your periodic table. Try to understand and focus on it. Two things are very important in the periodic table. First thing about the groups, and second thing about the periods. Okay, so the periods are moving from here and the groups are moving in this way. Okay, so you can see here, this your group 1 in which you have these elements.
How the period move?
Movement means to say you will move in a period. Groups from top to bottom, periods from left to right. And this a period, it's move like this, in this way. Okay, left to right. For example, in first period, like this first period, how many elements you can find? See my line. How many elements it cut? Only 2. Which one? One is the hydrogen and second is your helium. Understand? This is the
Yes.
first period. Now in second period and third period, how many elements? Who will tell me? In second and third, how many elements? Quickly.
8.
8. Very good. Now in fourth period, hurry up, hurry, quickly count.
12.
Okay, here 8, here also 8. So here to here 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Understand? 4 and 5. How many? 18. Understand?
Where's G A and G? It should be 15, 19, and
How?
the fourth one.
You count 19? You count 19? No, my dear, it's 18, not 19. Okay. So,
But the gallium
sorry?
and germanium,
No.
they
You
don't
can,
count.
I count everything. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay?
Yes, okay.
Okay. Now, let's see down. Inshallah, we will discuss this periodic table in detail also in the next section. But before to this, let's see the things here in detail. Now, whatever I tried to explain you, it's all written here. The periodic table, the above table is called the periodic table. Okay. That is the name of this table. It gives the name and symbols of the elements. All the atoms that are present, their name and symbol of all the elements are here. You can see anyone. Like this is uranium and its symbol is U. Too much information is here in the periodic table. The atomic masses, atomic numbers, where they present, they are metals or non-metals, everything will be you can find here. The columns and the rows are elements in the given a lot of clues about it. So the columns from up to down, these the columns, and the rows from left to right, which I name as group and periods. So look here. For example, it tells you 1, 2, 3 like this. The elements in these form family or groups. So like here, I will take you a little bit back up towards the periodic table. You can see here, this the group 1, okay? We also called them a family. Group 2 is a family. There are the names, okay? We also discussed the names like here, this the group number 7. We call this as halogen family because here we have fluorine, chlorine, bromine, iodine, and aspartame. These are the groups that in 7 and the name of the family is halogen. Understand? Or we also call them
Yes,
as,
and about the 0,
where is the 0?
the above, like krypton and
This one, yeah, this one.
yes.
Yeah, this is a 0 group. We also discuss it in detail. Don't worry. This is the, you can say that inert gases, noble gases, we name them. Inshallah, when we will come here, we will discuss also them in detail. Okay, so if you know how one element in group 1 behave, for example, you can make a good guess about the other. Like if I asked you the properties or the behavior of your brother, how likes, so it's mean you have almost the same behavior properties in yourself. Yeah, because you belong to a same family. Understand? So when we're going to see the characteristics of one element in one group, we can guess about the other properties of other elements. They are not exactly same, but they are little bit similar with many respects. Now, what about the rows? Now, the rows are called periods. Understand? These are the periods. We call them rows. Look at the zigzag lines. It separates metals from non-metals, while non-metals on the right of the line except the hydrogen. You can't put hydrogen in non-metals or in metals. So there is a change from metal to non-metal as shown across the period. So
Can you show us the zigzag?
no, why I show you? Definitely I will show you. Look here. This the zigzag, this one. Understand?
Yes.
Okay. So that zigzag, it's differentiate or telling you the left hand side mostly are the metals, and about this line, this zigzag line, the whatever the things here, these are mostly non-metals. And even when you
This
come,
except hydrogen, yes.
yeah, except hydrogen. So this one here, the hydrogen is not a metal. Okay, it's not even a metal. That's the reason they didn't place it here. Still, there are many questions where we place hydrogen. There are a lot of questions about it. Inshallah, we will discuss this thing also in detail. So here, this is the zero group actually. These are actually the gases. Okay, so this totally the metals and the non-metals, we separate them with the help of this line. Okay. Okay, after this, we move to the next part. Now look at the small numbers beside each symbol. These tells us a lot about the atom of the element, as we will soon see this one. Okay, so you can see that the couple of questions, what is a or an atom? B, an element. Number 2 question, if you could look inside an atom, what would you see? I think you know very well about them, yeah? Or I need to explain these questions?
Maybe like first. Like
Atom, you know that the smallest particle that you can't divide more, element, the pure substance, okay? So inside the atom, nucleus is present. Symbols of some elements comes from there. Later name, who discovered them mostly. So the later name of here written which element has this symbol Ca, Mg, and you try to solve these questions, okay? That is your small assessment, or you can say that as a small homework for you.
don't have it in the book.
Sorry? Yes,
You
Ahmed?
don't have it in the book. That is the old version you have.
Yeah, I know this is the old version. So now, more about atom. So let's see. I think this part I explained you in the basic. You remember? Okay. So let's see what is going to telling you here. Proton, neutrons, and electrons. Atom consists of nucleus and a cloud of electrons. What moves around the nucleus? The nucleus itself is a cluster of two kinds of particles, like proton and neutron. It's super easy. Yeah, all the particles in an atom are very light, so their mass is measured in the atomic mass unit rather than in grams. Protons and electrons are also have an electric charge. So here it tells you proton mass unit 1, positive charge. Neutrons mass unit 1, no charge, neither positive nor negative. Electron, almost nothing. Okay, it's not going to include in the unit, but negative charge. Since electrons are light, their mass is usually taken as zero.
You said, teacher,
Yeah,
there was internet lag.
who
Can
the
you repeat?
okay,
Me.
no problem. You can see here what we discussed in this chart or in this diagram. It's just telling you about proton, neutron, and electron. Proton unit 1, yani mass unit 1, you just take as a unit, not in grams, okay? Don't think it's mean 1 unit mean to say 1 gram. No, it's atomic mass unit. They have their own measurement units. Okay, we not measure because they are very small. So we can't make any small thing compared to the mass of the proton or neutron. So we measure in their own units. So proton unit 1, its mass and charge is +1. Same like electron, its charge is -1. But in case of neutron, no charge, but it's unit 1. Here in electron, there is no charge on proton, same like, sorry, neutron, but there is no mass of electron. So we make it as 0. Why we make or take it 0? Because it's very, very light. Understand?
Teacher, what is the charge?
Charge, this is the last one.
Yes.
Look, you know that even you have a battery, on the battery, there are two terminals. One is positive terminal, second is negative terminal. Okay. So the charge actually is, you can say that the electric charge. Okay. So if you let any particles in the difference, or you can say that in a potential difference of positive and negative, like here I let a proton, for example, this is a proton. If it moves towards negative end, we can say that it has a positive charge on it, because we know that negative and positive attracts each other. But in case of here, if I have an electron, this sorry,
You said if the electron move to the negative,
no, electron have negative charge, it move toward the positive end. I first tell you about the proton, it moved toward the negative end, but in case of electron, it moved to the positive end. So this is the charge, you can say that the density or the capacity or holding a charge itself. Okay. Okay, now how the particles are arranged. Let's see. Or you can say that the atomic structure. It's very easy to understand about this thing. The particles inside an atom. First of all, you should know that which atom is this one. This is a sodium atom. Okay, is good one to start with its 11 protons, 11 electrons, and 12 neutrons are there. They are arranged like this. What it means? How they are arranged themselves? That is the central part of the atom, which we name as nucleus. What we call this? Nucleus. Inside the nucleus, you have proton and neutrons clustered together in the center, forming the nucleus. This is the heaviest part of the atom. Now, around the nucleus, electrons are present in a circular form around the nucleus at different energy levels. From it, these energy levels are called shell. So what we name them, these are shells, where electrons revolve or move. Now, this is a very important note that just I explained you about the subatomic particles. Neutrons, protons, and electrons are often called subatomic particles. Till here, any question?
Proton and what are called subatomic particles?
Proton, neutrons, and electrons are called subatomic particles.
Okay.
Okay, there are many other subatomic particles, but we just discuss only these ones. Understand? Okay, now yes. Move towards the next part of the lesson. It's if you remember, I explained this, the proton number, or we also called it atomic number. Now, let's see again. Yes, Ahmed, do you remember or not?
Remember?
Okay. Now, the proton number, a sodium atom has 11 protons. This can be used to identify it. Since only a sodium atom has 11 protons, every other atom has a different number. What it means? Just same like your ID number, your passport number, or if you can say that your fingerprints, okay, or the iris, the eye inside this one, it is not going to match in this world with any other human being. Yes, in the same way, my dear, every atom has its own atomic number. That is the number of protons. So if any atom have like sodium, it has 11 proton, there is not any other element that has 11 protons. You can identify an atom by the number of protons in it. Understand? The number of proton in an atom is called proton number. So the proton number of a sodium is 11. You can see here 11 protons. What it means? Each has charge plus 1. So total charge on an atom is 11, because 1 proton carry 1 positive, 11 proton carry 11 positive charge. Now, let's see about the electrons. The sodium atom has also 11 electrons. So it has equal number of protons and electrons. This same is true for every sort of atom. What it means that if in an atom, the number of protons are always equal to number of electrons. Now you can see here 11 electron. Each electron minus 1. So total minus 11 electrons. So minus minus, you can say that cancel out each other. So adding the charges, you get 0. What it means? So the overall charge on an atom is 0. You can say that there is no charge on an atom. Now, let's see. Every atom has equal number of protons and electrons. So atoms have no overall charge. Look at the box on the right. It shows that the positive and the negative charges cancel each other for the sodium atom. That
How
is,
it have a charge of -1?
look, my dear, you have
Humanity.
I will tell you, listen. P4 positive plus minus 11. For example, here you have plus 10, okay? And here you have minus 5. Plus minus cancel each other? Yes or no? Yes or no?
Yes.
The same thing is going on here in the case of proton and electron. You can just imagine that both side, here is a rope, okay? And both side, who going to pull the rope, both side equal or same wrestlers, right? Both sides a big show, okay? Here is also a big show. Where this rope will go?
Oh,
Yeah, from both sides you putting or you force on the same energy. Yes, where this rope?
on the center.
Yeah, it will not go anywhere. It will stay here in the center. So in the same way, if plus here, minus here, but their numbers are equal, they will going to cancel each other. So the answer is 0. Understand?
Yes.
Okay, Alhamdulillah. Now you enjoying the lesson or not?
Yes, I understand.
Okay, because that I already explained you in the basics. Okay, nucleons number. What is nucleon number? Protons and neutrons. This very interesting topic. Okay, keep in your mind this one. Please focus here. From the nucleus. Yani if you can see that, that is an atom. Inside the atom, that is a nucleus. Inside the nucleus, two things, proton plus neutrons. Okay, so they both make the nucleus. Or we also called it as nucleons because these are present inside the nucleus. That's the reason we call them nucleons. This point easy? Understand?
Yes, but wait a minute.
Okay, just a listen. The total number of protons and neutrons in an atom is called nucleon number. What it means? In case of sodium, you know that their total number of protons are 11 and total number of neutrons are 12. 11 plus 12 give you 23. So this is the nucleon number of the sodium atom, that is 23. Okay, we also can say that this one is the mass number of the atom. Like here, you can describe any element in short way like this. Nucleon number at the top of the symbol. Proton number at the bottom of the symbol. And you can write like this. What it's mean? For example, in case of oxygen, just I'm going to explain this example. It's mean what I understand from here, 8. What is this 8? It's mean oxygen atom contain 8 protons. The protons are always equal to electrons. It means it also have 8 electrons. Sorry. Okay, now what about 16? Okay, this is the nucleons number. What it means? There are 8 protons and also 8 neutrons because 8 plus 8 equals 16. So that's a reason here they mention 16. Now, Ahmad, understand this thing? Yes, please. Hurry up. Ahmad, can you hear me? Amru, you have any question?
Yes, sir. Sorry, I had to
Uh-huh.
go. Emergency.
What happened? Yes, Amru, do you have any question till here? Okay, so let's see the.
I was gone because I had emergency and did not listen. What did you say?
Okay, no problem. No problem. Allah Kareem. Okay, Mr. Amru.
So,
Other number is the nucleon number. So we can tell straight away that sodium atom have 12 neutrons because when you minus this from nucleon's number, the number of proton, you get the answer 12. It means the neutrons are 12.